everyone, and welcome back to the last time for lesson 22.2. Today we are going to finish where we started on page 298, looking at number 6, which is going to start leading us back into the idea of general solutions. So if we look on our graphing calculators at where sine of x equals cosine of x. So we type sine of x in for the first equation, cosine of x into the second, and notice they want our interval to be over 0 to 2 pi. So we're going to double check that we are in radians mode, since we want 0 to 2 pi, and then we're going to adjust our window to be from 0 to 2 pi if we're not already. Right? And then scroll down, and then I'm going to have my graph go up by pi over 2. And then I'm from -4 to 4 for the y's, going up by 1. So we should be good there. And what we're going to see is when we graph these, so we have sine of x is the blue, cosine of x is the red, where they're equaling each other, where they're intersecting and overlapping, is halfway between pi over 2 at pi over 4, and then over here between pi and 3 pi over 2 at 5 pi over 4. So we have those two solutions to our question, right? And just looked at that from the graphing calculator on this, okay? Now, if we changed our window, however, to be from -2 pi to 2 pi, what we're going to see is on this graph, we have 4 solutions, right? We still have pi over 4 and 5 pi over 4, but since we expanded this a little bit to the left, we also have -3 pi over 4 and -7 pi over 4 as solutions as well. Right? So we have -7 pi over 4, -3 pi over 4, and then we still had pi over 4 and 5 pi over 4. And if we change the window one last time to 0 to 4 pi, again, we would see included in our answers pi over 4 and 5 pi over 4, but now we would also have 9 pi over 4 and 13 pi over 4. Okay, so what we're seeing is, again, dependent upon what range of values you are looking for, is going to kind of, 9 pi over 4 and 13 pi over 4. What we will see is that it's going to dictate what our solutions are, how many there are, what range we're looking at based on this interval. So if we were going to just say, okay, from -infinity to infinity, how many are we going to have? Well, infinitely, right? Because of those coterminal values going around and around and around the circle, we could have an infinite amount of answers, especially with that denominator of divided by 4, right, going around and around and around. So that goes back to our idea of general solutions, right? We talked about this in activity 20 as well. When we have the general solutions, you're trying to account for the fact that there are more than just 0 to 2 pi. So AKA the interval we look at there is from -infinity to +infinity, or they'll say the general solutions, okay? Reminder, it's 2 pi k or 360k, usually, like depending on radians versus degrees. Sometimes you will use pi k or 180k for tangent, especially because it repeats every other quadrant, or in special case situations, you might use it with cosine and sine, depending on if it's repeating more often or not. Let's say if it's like a plus or minus idea. Okay, so again, k is just an integer value to kind of show us that. And a lot of times you use either just plus sign, since k can be negative. I sometimes like to write plus or minus. Okay, so we have some more trig examples to solve, and with the general solutions, in this particular one, if we start solving to isolate sine, we would subtract 1 and divide by the square root of 2, and after rationalizing, we're looking where is sine negative square root of 2 over 2. Well, because we're going from -infinity to infinity, we do want to consider first 0 to 360 degrees, right? So if we were just saying 0 to 360, our two answers would be 225 and 315, or 5 pi over 4 and 7 pi over 4 if we were in radians. But because we want the interval from -infinity to infinity, or the general solutions, we want to make sure we include adding or subtracting 5 360k since this is degrees. And again, you could just write plus. I like to do plus or minus to show that. So this would be our answers for that interval from negative infinity to positive infinity. So still just kind of looking at the values from 0 to 2 pi and then generalizing. On this next example, we have 2x squared minus x minus 3. If we want to think about this in terms to help us factor a little bit easier. And what multiplies to be negative 6 adds to be negative 1. Well, that's going to be negative 3 and positive 2. And so again, if we write these broken up and factor by grouping, we will see that we have a factor of x, and we're left with 2x minus 3. No greatest common factor means that it's just 1. And we end up with 2x minus 3 as a factor and x plus 1 as a factor. Okay? And when we substitute back in the tangent, we have 2 tan of x minus 3 equal to 0, or theta, I guess they were calling it, and tangent of theta plus 1 equal to 0. So we again are going to have multiple solutions, because when we set tangent of theta equal to 3/2, if we approximate this using our graphing calculator, again, we'll use degrees for right now versus radians, tan inverse of 3/2 is 56.3. And again, we just want positive 3/2. So that's actually going to be taken every other quadrant. So quadrant 3 would be the plus or minus 180k. And since it's repeating more often with tangent, that's why we're going to use the 180k. When in doubt, though, you could also have double checked that, the quadrant 3 value to this is 180. If you listed both, I wouldn't mark you wrong. But again, you're kind of picking that up already by just saying 180k. And then the other piece of this is, where is tangent of theta equal to negative 1? Well, tangent's negative 1 at 135 degrees and 315 degrees. And again, because you're repeating every other quadrant, though, you could just kind of summarize this with 180k, and 180 added on to the 135 picks up the 315. So you kind of don't have to worry about it. Really, you could just leave it as these two answers. Now, again, if you wrote 135 plus or minus 180k and the 315 plus or minus 180k, that's okay too. Because again, with tangent, it repeats more often. So we can use the 180. All right, last two examples then that we have are examples C and D for this piece. And we talked about before and the other day about substituting 1 minus sine squared for cosine squared, because now everything is in terms of sine. And if we move everything over, we end up with 0 equals sine squared minus sine. Take out that GCF, and we end up with sine factored out 1 minus sine, still left in. And we had sine is equal to 0 or 1. So we have to be careful because sine's going to repeat. Sine is 0 at 90 or 270. So we can just say 90 plus or minus 180k, and that's going to help pick up the 270 as well. And then sine is equal to, that's for 0. So the 90 actually goes down here. This is actually going to be 360k because we're not plus or minus. Here, sine is 0 at either 0 or 180. So just saying 0 plus or minus 180k works as well. Or you could write this one as 0 plus or minus 360k and 180 plus or minus 360k if you would rather look for both solutions and just write plus or minus 360. And if we were talking about our last example, sine equaling cosine, that was 45 degrees and, beyond. And so this was happening at 45 degrees plus or minus 360 and 225 plus or minus 360. Or you could have written this as just 45 plus or minus 180. You have options. Okay. So that kind of concludes our talk again about our general solutions. A reminder, when in doubt for sine and cosine, always use 2 pi k or 360k, but if you can simplify how you write your answers, 180 works as well. Thanks for watching, and we'll work more with this in class.